All right, let's talk about Cisco device upgrades. By the time we're done here, we will examine the common interface modules installed in Cisco routers and switches to provide added connectivity. Whew, that's a mouthful. Big picture, I want to make sure as you build your physical lab environment, you know what options you have to make sure these things can get the connectivity that you need to do all of your testing. And I also want you to know that the stuff we're talking about right now, when we're talking about the modules you can get and the upgrades to get for your different devices, go way beyond building a physical lab. You do this all the time in the real world as you spec out your devices, and there's probably no place that I've made more mistakes than this. So I want to share some of those with you so that you can avoid them because they typically are costly. Buying the wrong thing costs you time and it costs you money. So big picture, know that there are two types of Cisco devices. There's modular and there's fixed. Fixed interface devices are what they are. You get them from the factory and you put them in the rack and they start doing what they do. Now some of you might look and go, well, wait a sec, what about those guys? Yeah, you're 100% right. What about those guys? Those are known as SFP ports. It stands for small form factor pluggable. Often you'll hear these things referred to as personality modules because these really are designed around one type of interface, even though it's not limited to them, of fiber optic. It's fiber optic connectivity for your devices. Fiber optic cable will allow you to transmit much farther and with increased speed. And we could argue about those and say, well, those are modules. Yeah, they are modules, but I'm not going to count them for at least this discussion right here. That's really a fixed interface switch. This is the kind of modular that I'm talking about. And you can see right here is some fixed interface. Actually, I'm gonna break this device down in just a minute. So you can see these are where you are able to add your modules. These guys, all different sizes, shapes. And same thing right here. On this type of device, this is a chassis-based switch. You don't usually call these modules. You'll call them blades. You'll put blades in place, and inside of those blades, that's where you'll install your modules. So what kind of things can you install inside of your device? Well, we talked in a previous video about memory, flash and RAM, but I'm just going to leave that to a different discussion. That's not adding interfaces. It's not really adding functionality. It's just adding memory. And adding memory is adding memory. It's the same thing as what you do on a computer, on a router, on a switch. You put the chip in there and ta-da, memory. When I'm talking about modules, I'm talking about these or these. These ports, this size, matter of fact, this right here is a VIC card. It's a voice interface card. See, our routers have the ability to interface with data networks and voice. So I can actually, these are, oh, look at that. These are two FXS ports. These are analog phone lines because in our voice over IP world, we might have certain devices like emergency phones that are in an elevator or a phone on the dock of a shipping bay that sits out in the rain where a voice over IP phone isn't appropriate, but we have a voice over IP network. What's a network admin to do? Get one of these modules, run a typical traditional phone line to the device, and bada bing, you have a module that can convert a normal phone or modem or fax machine, I'm just giving you ideas, into a voice over IP device. That's an example of a VIC card. It would slide right into one of these slots, and as long as the router had the feature set, meaning it was built to interface with voice over IP networks, it's part of its capabilities, and you have the iOS version installed on it that gives you that level of support, which means you've paid Cisco some money, boom, your voice interface card begins working. WIC card stands for WAN interface cards, and I'll show you those in just a second. Let me talk about these. These are, I don't know why, every time I see this single wide and double wide, I think of those big old mobile trailer homes going down the road, and you're like, I can't get around them. The single wide modules are a common size, as in every Cisco router that has the capability of supporting a single wide module all have the same size of these. Usually, these are carrier modules, meaning if you need more VIC or interface cards than you have real estate for here, you can buy a carrier module, and that carrier will have the resources on there to support additional VIC cards or WIC cards or whatever you're trying to add. Remember, the motherboard of this device can only handle so much, so it's kind of like you add an add-on card, if you will, and then you can install more VIC and WIC cards. This router right here is special in that you can remove this bar in the middle and take this entire thing up by one double wide module. So in this case, we could install either 2 single wide modules or remove the whole thing. And you might go, well, what's a double wide? You can actually install an ether switch module. That's the most common double wide that I've seen, to where you've got a small office environment where you're like, hey, I have 10, 20 ports here. You can install a 48 port or a 24 port ether switch module inside of that double wide slot that does power over Ethernet. It does all kinds of switch functionality built right into that router. That's what that double wide slot makes possible. Now, what about the modules? What do they do? What functionality do they provide? Well, you can see right here, this is an example of a single wide module. And just, I don't know if you can see underneath, that's the miniature motherboard, if you will, that provides the resources necessary to power the 2 VIC/WIC cards, whichever capabilities this single wide module has, in addition to providing 2 fast Ethernet ports in this case. As a matter of fact, I gave you the exact model number of what this single wide module does. If I wanted to add 2 fast Ethernet ports and the ability to add 2 VIC or WIC cards, I would buy one of these guys. Modules can also provide other functionality or resources to your device. For instance, this is an NMHDV2. It provides DSPs, that stands for Digital Signal Processors. So the idea of converting voice into packets takes work, a lot of work. I mean, think about what's happening right now. I'm speaking into this little microphone, and something inside of a computer is like, like I think of one of those chefs with the Jinsu knives. He's like, it's chopping up all my words into these tiny little 20 millisecond packets, right? That takes work, and your routers don't have the processor to be able to handle that. So they have digital signal processors that you can add where it can take tons of voice conversations. And by the way, these are T1 ports, which allow you to interface with a bulk voice connection where you can have a bunch of conversations all simultaneously coming into this guy. And right there is your Jinsu knives. That's the processor, the digital signal processors to chop those up. You're adding resources to your router to give it the capability to handle more voice sessions. This is an ether switch module. That's the functionality. I want my router to be a switch too. Well, by golly, we've got a 16-port ether switch module. It even does power over Ethernet. All of these model numbers mean something, and I don't know. You won't have to know. I don't know. You shouldn't know unless you do this all the time and you're buying modules as part of your trade. What each one of those characters mean, that's what websites are made for. They'll give you all of the reference that explains that to you. So lastly, what about the cards? What about the cards that you can install inside of that single wide module? Namely, the WIC and VIC cards. These are just some examples. WIC is WAN interface card. It gives you wide area network connections. This is an example of a DSL port. So you can install a WIC card that allows you to interface directly with a DSL connection. Or this guy. This is a WIC2T. Super common in the old days when serial connections ruled the world. And there's still a lot of serial connections out there. These are what give you connections like frame relay, ATM, a lot of other a direct point-to-point, like when somebody says, I've got a T1 line connecting these 2 sites, typically that's a serial connection. And this WIC card gives you 2 serial ports, which in a physical lab environment allows you to have a couple routers, and you can just, they're a couple feet away from each other, connect a serial crossover cable, and then create your make-believe world. This router right here connects to Las Vegas. And you plug it into your switch and all the different devices plug into that. This one up here connects to Arizona. So you plug that into a switch and plug in all your devices right here. You've got a serial port. The only difference between this and the real world is that is a couple feet versus a few hundred miles. Otherwise, all the functionality is the same. When it comes to the VIC cards, this is literally what I haven't put it down. I'm still holding it this whole time. Literally what I'm holding in my hand right now. This is, can you see it? VIC, right there, that's hard. VIC2 FXS, right? Gives 2 foreign exchange station. It took me a sec to remember that. At foreign exchange, where X is the big station. So you can plug in a analog device, a modem, a fax, old rotary phone, doesn't matter. This little gem takes it and converts it into a voice over IP system. This does exactly the same thing as this, but instead of analog, this does it for digital ports, such as T1 or E1 interfaces if you're living in another part of the world beyond the United States. All right, I said last thing, but I have one more last thing. And that is the blade switches. And again, I'm saying the SFPs don't count. You can see SFP slots, SFP slots, SFP slots. There's just SFP slots all over the place. And there's a whole flurry of SFPs that you can get. Again, most of those geared around connecting to fiber optic networks. Let's talk about the blades. The blades are typically one of two things. And I'm not going to limit it. You can be more. But it's usually either supervisor engines or interface modules. The supervisor engines, for example, this is the SUP 720 that goes right into one of the 6500 switches, provide the brain, the intelligence of the switch, and provide the level of performance that you're going to get out of the switch. That's the beauty of the chassis-based switches, and why, even though Cisco started manufacturing them probably 2004, was when the 6500 switch came out, and they stayed alive for literally decades, is because to upgrade, decades, how about a decade or more, is because you could take the supervisor engine out, add an upgraded supervisor engine, and now that switch is good for years to come. The supervisor engine, and notice I keep saying engines, have the memory and the processor and all the functionality. It's like ripping out the motherboard of your computer and giving your system a complete upgrade. That's a big deal. The reason I keep stumbling over myself and say engines, like you can see two of them right there, is because you'll usually, in a big switch like that, add two for failover. Is it costly? Yeah, really costly. But imagine how costly it would be if a switch like this, think of each one of those as a salary of somebody. 2 salaries, 3 salaries, 4 salaries. You get the point. If that switch goes down, all those people stop working. And it doesn't take long to recoup that cost of lost productivity and opportunity cost of work they couldn't do because you didn't have a second supervisor engine or a second power supply. Redundancy. You'll hear the theme, 2 is 1, 1 is none in the realm of network technology. The other module that you can add is pure interfaces, and you see them here and here and here. Now you can also see there's other modules than just straight Ethernet ports, because there's other kind of connectivity in the network environment. You can even add wireless controllers to these switches, which control a whole bunch of wireless access points. My point is, everything's expandable, and as you build your physical lab environment, look at what you're going to need to connect to. Have a plan. Don't just go out and start buying modules. Have a plan of what kind of connectivity you're going to need. Then research exactly what modules are compatible and any increased memory requirements that you have. There's nothing worse than buying a module and plugging it in and the router no longer boots, or boots up and crashes, or it boots just fine and then you go to do a show command to find that module and it's like, oh, that's not supported. That's a different one. These are common form factors. Just because they fit doesn't mean it's going to work. iOS version, hardware version, memory requirements, they all have to align. So be sure when you're looking at one of these guys on eBay, you find out what are all the things that are needed to support that device on my router or my switch platform. You've now seen the common interface modules installed in Cisco routers and switches to provide added connectivity or resources or functionality. I hope this has been informative for you, and I'd like to thank you for viewing.